Hi, in this video we are going to talk about the implementation of the depth-first search, the second important graph traversal algorithm. So let's get started. We are going to define again a node that's going to represent the nodes or vertices in the graph. It's going to have a constructor with the init method. We are going to define a name for every single node in the tree-like structure. Then we are going to have the self name is equal to the name. The self.adjacencies list is equal to an empty array or list in Python. Then we are going to have the visited boolean initialized to be false. And we have the self.predecessor. Okay, we are not going to use it, I think, because we haven't used it in the breadth-first search implementation, but sometimes it can prove to be very important. As we have discussed in the theoretical section, or I'm not sure, maybe we are going to talk about it in the shortest path section, that breadth-first search can be used for shortest path algorithms as well. And that's why the predecessor can prove to be very important. Okay, and I'm going to have the class depth-first search with the object. And we are going to have the DFS method, not BFS, but DFS with the self and the name. And, oh, sorry for that, it's not going to get the name, but the start node. So it's going to get a node from where we are going to start our algorithm. First, we set it to be visited. So node visited is equal to true. I'm going to implement it in a recursive manner. We could implement depth-first search approximately the same as we have implemented breadth-first search, but instead of using a queue abstract data type, we have to use a stack abstract data type for depth-first search. And again, I don't want to repeat myself over and over again, but it is a quite common interview question that what's the main difference between implementing depth-first search and breadth-first search. For breadth-first search, so BFS, we use a queue, as we have discussed. For DFS, so depth-first search, we use a stack. But we can implement depth-first search in a recursive manner, so we don't have to use a stack because we are going to use the operating system stack. So in the below level, in the background, under the hood, a stack is going to be used, but we don't have to bother about it. The operating system is going to handle this stack. Okay, so we set it to be visited, then we print it out, so we print out a string and node dot, I think we have the name, okay? And we just have to iterate through, so basically visit every single neighbor, so adjacencies list, and if we haven't visited that given node, so not and dot visited, it means that if we haven't visited that given node, we just have to call this method recursively DFS on the neighbors. I think it is a beautiful algorithm. Depth-first search can be implemented in a recursive manner. Breadth-first search, we are not able to implement breadth-first search on a recursive manner. That's why we have used the queue underlying abstract data type. For depth-first search, we could use stack, but I like the recursive implementation. We get a node, we print it out, we set it to be visited, we visit all the neighbors and call the method recursively if we haven't visited a given node. And that's all about it. In case you have forgot about the concrete algorithm, for depth-first search we keep going as deep into the tree-like structure as possible. So instead of visiting the neighbors, we keep going to the left branch, for example. It's very, very important to know that we could choose the right subtree as well. So we could visit the right subtree elements instead of the left subtree. It doesn't matter. It's a matter of implementation. So A, B, C, then we backtrack, D, E, we backtrack, okay. We visit the F, then we visit the G and the H. As you can see, we keep going, so A, B, C, D, E, F, G, H. What was the breadth-first order? We visited A, then B, F, G, then CD, H, then E. So for breadth first search, it is a layer by layer algorithm. For depth first search, we keep going as deep as possible into the tree. It doesn't matter whether we keep going to the left or keep going to the right. We just have to be self-consistent. So if we keep going to the left, then we have to take the leftmost items as possible. If we keep going to the right, then we have to keep visiting the rightmost item, which means that if the G has a right child, then we have to visit the right child before we visit the left child. So, okay, we have to be self-consistent, but it doesn't matter whether we take the left subtree or the right subtree. So let's see whether it's working fine or not. I have the node 1 with the node, for example, A. I'm going to create the same tree-like structure as for BFS. I think we have the B, then we have the D, then we have the, oh, sorry for that, A, B, C, D, and E. And of course node 2, node 3, node 4, node 5. Okay, so we just have to handle the neighbors. So adjacencies list.append, we have to append the node 2. Then I'm going to append the node 3 as well. Then I'm going to append the node 4 and the node 5, but not for the node 1. It's going to be the neighbor of node 2 and the node 4. Sorry for that, 4. Okay, and then we just have to initialize this depth first search, and we just have to call the DFS method on this DFS object, and the starting node is going to be the node 1. So let's see what's going to be the result. We just have to type python dfs.py. As you can see, we have the A, B, D, E. Okay, something's wrong because I forget to update it from node 2 to node 3. Sorry for that. So node 1 has the children 2 and 3, then 2 has the node 4, and the 4 has the node 5. Okay, let's see whether it's working fine. A, B, D, E, C. Yeah, it's going to be the depth first order. Instead of going on a layer by layer basis, we keep going as deep into the tree as possible. So that's the most important difference between depth first search and breadth first search. I'm going to make a comment. So for breadth first search, it's very important that we have to use a queue. So we use a queue plus a layer by layer algorithm. Okay, on the other hand, we have the depth first search. It's going to use a stack. Okay, we don't use a stack here because we can implement it in a recursive manner. And if we use recursion, then we have the operating system stack that's going to be used. And it's very important that goes as deep as possible into the tree. Okay. So that's the main difference between breadth first search and depth first search, and this is how we implement it in Python. Thanks for watching.